Hello everyone, welcome to another one of our research videos where we give a brief summary of scientific research we have done. I'm Tom Mackay-Smith, co-founder of Vedantia Research, and I'm going to share one of my research projects I did during my PhD at Massey University. In this video, we're going to explore the impact of Kānuka silvopastoral trees on surface runoff and nutrient loss. So the first thing to say really is sediment and nutrient losses can be significant in hill country. So this was reviewed by McDowell et al. In 2008. And they found on average total N can be about 11 kilograms per hectare per year. Total P can be 1.3 kilograms per hectare per year. And there can be just over 1,000 kilograms per hectare per year for suspended sediment on average. And so obviously this is a loss from the farm, but also leads to downstream issues in terms of water quality. And if we look at the discharge rates in an agricultural catchment, so this is the rate at which water moves through the catchment after a rainfall event. So this is a rainfall event here. And this black line is the discharge in an agricultural catchment, and it's about about 600 litres per second at its peak. And here we have the nutrient concentration and also sediment concentration. And if we compare this to a forested catchment, so this is both hill country catchments in the Manawatu, really close to each other. If we compare this to a forested catchment, a similar sized rainfall event, if we look at the total flow discharge, it's only 14 litres per second in the forested catchment, but nearly 600 litres per second in the agricultural catchment. So a massive difference there. There's also a big difference in the nutrient concentration, about half the nutrient concentration in the forested catchment compared to the agricultural catchment. And the sediment concentration was significantly less in the forested catchment. So we know if there's trees there in a forest, we can really reduce the amount of water that gets through. They act as a sponge, reducing water getting through the catchment, and also nutrients lost from the catchment. So obviously if there's less discharge in hill country, there's reduced flooding, and if there's less nutrient and sediment loss, there's cleaner waterways. So silvopastures can also reduce surface runoff. So when you integrate trees within paddocks and you continue to graze the land. So this was a review done by Zhu et al. In 2021. And they looked at 6 case studies of silvopastoral systems around the world. And they found on average 45 to 88% less surface runoff in silvopastoral systems. And average nutrient loss reductions were 47% in surface runoff in silvopastoral systems. So really good evidence that these type of systems could reduce surface runoff, discharge rates, and nutrient loss and sediment loss in hill country catchments. So this is a silvopastoral system in hill country using Kānuka. So the primary objectives of this research project was to measure the impact of individually spaced Kānuka trees on surface runoff and also nutrient and sediment loss. In terms of the study design, we did this study at one site in the Wairarapa, and we took measurements over a 1-year period from May 2020 to May 2021. And we basically had 2 plots. We had an open pasture plot, so a plot without any trees, and a tree pasture plot with spaced Kānuka in the plots. And we had 3 replicates of each plot, and the slope was around 25 to 28 degrees in all the plots. And this is what the study design looked like. So we had our 3 open pasture plots here, and then we had 3 under the trees. So surface runoff happens in these plots, and it's collected here in these gutters, and then it goes through this pipe into this box here. And then in the box here, we have tipping buckets that tip every time they fill up, so we can record the amount of surface runoff there is. And the water is collected in these buckets down here, and then we collect that water and we calculate the nutrient concentration and the sediment concentration, and then we can calculate sediment and nutrient loads for the catchment. This is an example of the tree pasture plot here, and this is the open pasture plot. So in terms of the results, over the year we had 23 surface runoff generating events. And in terms of the amount of surface runoff, there was actually very little surface runoff overall in the tree pasture and the open pasture plots. So this is the average surface runoff per event, about 2.3 millimeters in the tree pasture, about 0.3 in the open pasture. It obviously ranged tremendously depending on the size of the rainfall event and the rate of the rainfall event. But in the tree pasture, it ranged from 0.02 to 9.57, and open pasture was 0 to 3. In terms of cumulative runoff over the year, so how much total runoff was there through the year, there was only 53 millimeters in the tree pasture plots and about 7.5 in the open pasture plots. So it was about 7% of rainfall in tree pasture, 1% of rainfall in open pasture. This was the opposite of what we expected. We actually thought there would be less surface runoff in the trees because some of the water is absorbed by, is intercepted by the trees. We also thought there'd be increased porosity, increased draining into the soil, but this was the opposite of what we found. In terms of sediment and P losses, average annual loads for suspended sediment was 37 kilograms per hectare per year in tree pasture and 4.7 in open pasture. And total P was about 2 kilograms per hectare per year in tree pasture and 0.1 kilograms per hectare per year in open pasture. And in terms of how these compare to averages in hill country, suspended sediment in our study was very low in both tree pasture and open pasture, but total P was high in the tree pasture plots, but very low in the open pasture plots. If we look at N losses, it was about 5.5 total N kilograms per hectare per year in the tree pasture and 0.3 kilograms per hectare per year in the open pasture plots. And if we compare this to averages in hill country, the open pasture was very small and the tree pasture was about half of the average amount that we'd expect in hill country. In terms of the relationship, there was a very, very strong relationship between the loads and the surface runoff. So when you increased surface runoff, you increased the loads in hill country. So if you can mitigate the amount of surface runoff that happens in hill country, you can mitigate the amount of nutrients that are lost in hill country. And we saw this trend in all of the relationships except ammoniacal N in open pasture. So why did we see these results? So now we're going to kind of dig into some results, some kind of results on the plots to really understand why we might have got those findings. So we found very high Olsen P in the tree pasture plots, very high total N% and high potassium levels in the tree pasture plots. We also saw very high organic matter percent in the tree pasture plots, high cation exchange capacity and high sulfate. We also found significantly greater porosity in the tree pasture plots and significantly greater soil moisture in the open pasture plots. So it was clear that there was more nutrients in the soil in the tree pasture plots and the porosity and the organic matter was greater. But this really didn't explain why we got an increase in surface runoff in the tree pasture plots, because with these results we would expect the opposite. So then we took some readings into the actual grass that was on the slopes because we thought this might have an effect. So we measured grass height halfway through the year over about 12 of the surface runoff events, and we found significantly greater grass height in the open pasture plots. And the big one was grass biomass. So this was a physical amount of standing grass biomass at various surface runoff events, and we actually found significantly greater grass biomass in the open pasture plots when there was surface runoff events. So this isn't overall production over the year, just how much physical grass was sitting there at each of the surface runoff events. And you can really clearly see this result here with a thick bed of pasture that hasn't been grazed in the open pasture plots. Different time of year, very similar result. But when you go under the trees, the pasture was very clearly selectively grazed under the trees and not grazed away from the trees. So what we thought was going on is the animals were spending more time under the trees because of the shade. There was increased nutrients under the shade, and they were also grazing the pasture there, which meant there was more surface runoff happening under the trees because there was less grass as a physical barrier to surface runoff. So just to summarise, in the open pasture plots it was less fertile, reduced porosity, but there was, because of this, less grazing, and because there was less grazing there was more grass on the slope and so less surface runoff. Under the trees it was more fertile, it was greater porosity, so there was more grazing under the trees because the grass was more favourable to the animals, and then there was more surface runoff. So these results were not the results we were expecting, but they were really interesting results nonetheless. I guess one of the key points is in both the plots surface runoff was very low, but loads were still high. But a really key way of controlling the amount of surface runoff is to mitigate the amount of grass that is physically growing on the slope. So if you control that, you can control the amount of water that is lost. But we really think these results is a result of the spatial distribution of trees within the paddocks. So there was very clear tree pasture areas and open pasture areas. And when you find that, of course the animals are going to spend more time under the trees, and there's going to be this big disparity between the tree pasture and the open pasture environment. So we think this is a product of the spatial distribution of trees within the paddock. And something we're really interested in finding out, and something we think would create different results, is if it was a more even distribution of trees within the paddock. So you're creating one complete tree pasture environment, you're not creating these separate tree pasture and open pasture environments. Then we think the trees could have a more positive effect. So this research has been published in a peer-reviewed journal article, so if you would like access to that study, then please get in touch and I can send it to you. The funders for this project were mainly Massey University, that funded me through a Massey doctoral scholarship, as well as funding from Greater Wellington in Masterton, from Manaki Whenua, and also the C. Alma Baker Trust. Thank you very much for listening. If you have any questions or any thoughts, any queries, we'd love to hear from you. Please reach out using the contact form on our website. Thank you very much.